This is Marila from Marcus Evans. Thank you all for joining today's webinar on achieving carbon neutrality by 2050, a tangible possibility or a far-fetched story, brought to you in partnership with REXA. Before we begin, I would like to cover a few housekeeping items. As you can see at the bottom of your screen are multiple application widgets that you can use. All the widgets are resizable and movable, so please feel free to move them around. If you have any questions during the webinar, you can submit them to the Q&A widget. We'll try to answer as many questions as possible. However, if we run out of time, we'll make sure to answer to you via email. If you want to download any resources or any slides that you can see on your screen, please download them from the resources widget. Or if you need any help, please click on the help widget. At this point, I will briefly introduce our moderator for today, Daniel Gregory, West Coast Regional Sales Manager from REXA. Dan, you can take the stand.
Welcome, everyone. Thank you for joining. So we'd like to start this webinar, and I'd like to go through the agenda. But before we do that, if each moderator can introduce themselves and tell us a little bit about yourself, we can begin the questions and answers. We'll start with Walter first, then we'll go to Ben, and then Christopher. So Walter.
Thank you, Dan, very much. I'm Walter Gull. I'm President and General Manager of Petrochemical USA. I've been in the fired heater and furnace industry for over 35 years, starting my career focused in on the supply of the equipment, but very quickly changing over time to really focus in on what solutions are needed for existing fired equipment, and really just working closely with the owner operators to understand what their needs are for this existing equipment.
Excellent, Walter. Thank you so much. Ben?
Yes, good afternoon all. My name is Ben Mitchell, and I have been in the field of health, safety, risk management, environmental for over 30 years. Started off my career for over 21 years at the Hess Oil Refinery here in the United States and also in the U.S. Virgin Islands, and then pushed off taking some challenging roles at the senior level with companies such as Coke, Lubrizol, BP, and INEOS. And I am currently the director of HSSE for Kaneka North America here in Houston, Texas. My primary focus has always been risk management and trying to help manufacturing companies develop, maintain, and sustain what we call a zero incident type culture. I'm also retired from the U.S. Army as a colonel. Thank you.
Thank you, Ben, so much. Christopher.
Hello, everyone. Chris Clinton. I have been in the industry for over 20 years. My background's in chemical engineering, and I grew up in the industry primarily as a tried and true operations professional. I started off working in a pilot plant, then various roles within the production ranks here at around the Deer Park, LaPorte, Texas area. And so, spent most of my formative years at the Lubrizol Corporation in various roles, again, mostly operations with a stint in a strategic planning role as well. Currently, I'm the site director for INEOS Oligomers located in LaPorte, Texas. That's about 20 miles east of downtown Houston, and responsible for all site functions. And again, I mean, truly from an end user ops accountability point of view, definitely can speak to our topic today with lots of experience. Thank you very much.
Well, thank you all. I know for me, this will be a great opportunity to learn from so many of you on this panel with so many years of experience. I'd like to just take a message and start with a little bit about what REXA actuation is. We are a critical control device, and over the years, we have been put into applications in and around the industries that we'll be discussing today, and we deliver a high performance actuation service and consulting. We're able to customize our product to meet the application needs. Certainly within the fired heater world, we have been used for critical damper control to add into companies like Petrochemical USA's complete solution and overall fired heater air, O2, and draft control. We have a very simple, unique technology. As a final control element, we're able to remove some of the unburdens and accessories and be a very simple, powerful, and accurate final control element for applications within these industries. So today we're going to focus in and around fired heater conditions, meeting government imposed emission regulations. We're going to be looking at preventing costly damages of fired heaters, sustaining and correcting furnace draft. These are just some of the value messages that go along with the control solution, and minimizing really risk. And the overall, I think, benefit to all of what we do is promoting a safer operation for the company and its employees. So without further ado, we're going to go and move forward into the questions. I'm going to ask you, the panel, a series of questions, and everyone will have the opportunity to respond. I think this first question will be basically for all of you. We'll start with Walter, then we'll go to Ben, and then Chris, you can supply your final thoughts. So Walter, have you had, with the new state and federal emission regulations aimed at achieving carbon neutrality, most affected by the petrochemical and refinery operations? I mean, really, how has that process started?
Well, at this particular stage, a lot of folks right now in the industry are exploring what options they have available. And at this particular point, traditionally, from an emission standpoint, it's been NOx and CO that have been regulated. This newer green or carbon neutral perspective really hasn't been captured yet in most of the regulatory requirements, but everybody is expecting it to be pretty soon. And so there are a lot of questions, a lot of discussions taking place right now about what can we do with our existing equipment to make them as carbon neutral as possible. And of course, fired heaters and furnaces with the fuel that's necessary to burn to provide the energy that's required for the processes, they're pretty high on the list when you look at your typical petrochemical or refinery type process.
Chris, your comments.
Yeah, I think that the first two panelists pretty much summarized the critical points here. I mean, the one thing that I'll add to the discussion, depending on your location globally, can have a really big impact on how fast or how aggressive that you have to move in order to become more compliant, with the government mandated regulations. And again, it's just, I think it's quickly becoming a state of business and how we have to adapt. I mean, just like some of the other things we've traditionally monitored and have been controlled from a federal standpoint. But again, I think it just changes the way we do business, from here on out.
Oh, thank you, Chris. Yeah, I get the feeling overwhelmingly in the downstream market, there appears to be a push, and oftentimes projects that are funded regarding carbon credits and meeting these environmental regulations. So I thank you all for your comments on that. I think we'll move to the next question. And this question has to do with efficiency and emissions. And what we'll do is we'll direct this first to Walter, and then from Walter, we can go to Chris and then to Ben. Walter, what are some of the new technologies and equipment improvement opportunities available to drive increased efficiency, decrease unwanted emissions, and meet environmental goals?
Dan, I think you're the one that drafted this question, so kudos to you, because it's very simple on one level, in that if you can increase the efficiency of the equipment, specifically the fired equipment that's running 24/7, you're going to burn less fuel and you're going to decrease the amount of emissions that you emit for that particular piece of equipment. So a lot of focus today And a lot of the conversations, specifically when it comes to fired equipment, are focused on increasing the efficiency. Now, historically, a lot of folks would add additional surface area in a convection section if your flue gas temperatures were hotter, trying to, again, improve the efficiency, or they would retrofit with perhaps an air preheat system, again, to increase the efficiency. But what has recently had a lot of focus, which is tied to some of these newer technologies that are out there, is being able to operate that heater that was built 30, 40 years ago and do so with a significant amount of reduced air. Because for every bit of additional air that you have entering that firebox that you do not need for combustion, you have to burn additional fuel to heat it up so it's not cooling things off. So the technologies are really focused on some of the stuff that we work with Rexa on, regarding damper technologies, the improved controllability of those dampers, automating the amount of combustion air that comes in through the burners. Those are also technologies that are being heavily focused on.
Oh, you bring up some great points, Walter. I mean, really, when we're involved in some of the projects that you've done, I mean, removing some of the operational uncertainties, removing some fail points, ensuring to the end user that when they're asked to move a damper, that the damper moves instantly and then can hydraulically lock in place, kind of improves that process. And to your point, with the reduction of excess air and not having to heat as much air, we've certainly received a number of feedback on the cost savings, and again, driving back to a safer operating furnace. You bring some great points. Thank you so much. Chris?
Yeah, absolutely got some feedback on this one, and it's actually very ironic. I was having a conversation earlier this week about some of the fired equipment within my own facility, and I think Walter's point hit home, because quite frankly, I've got about a 30-year age difference between the oldest and the newest piece of equipment. The newest equipment actually delivers quite a high load, but it's much more efficient. And we've talked a lot about efficiency, right? I mean, right now, natural gas, isn't necessarily the most expensive utility, but that could change in due time. But really, what was sort of the main point of this conversation was the CO2 emissions that comes along with that inefficiency. So, I mean, kind of going back to the CO2 reduction topic, I mean, it's a huge opportunity, and the way I look at it, fired equipment, not so much flares and incinerators, but boilers and furnaces for hot oil especially, aren't necessarily target pieces of equipment to upgrade and or replace, a lot of facilities from just a financial point of view. But I think technology here, I mean, really changes the discussion, changes the justification, and our discussion on the first question really illustrates that there's a much stronger business case to look at this in more detail in today's day.
Oh, thank you, Chris. You bring up some great points. Ben, what suggestions do you have or information on this question?
I'm enjoying this panel because you got the engineering experts, and then you have a safety and risk manager expert. So I'll tell you what's important to me. As we look at automated upgrades to our technologies, it's important that we use a good digital compliance platform, some type of software to help you with these efficiencies, particularly as it impacts the environment. So what am I talking about? I'm talking about making sure that you get yourself a good digital software program that can help you set your GHS targets and your emission targets as we all work towards net zero.
Oh, that's great to know. One of the things that we've noticed, certainly in the actuation side and the control side as the final control element, is that a number of our customers realize relatively quickly that without going through external devices, that in their controls loop, the minute they ask these dampers to move, they move within milliseconds. So you bring up a great point regarding controls and other instrumentation. Any other comments on this questions?
Dan,
Okay.
this is Walter. Yeah, I would like
Sure.
to add one more thing on top of what these other two gentlemen shared. You know, what we're really finding is that for years, much when it came to controlling excess CO2 on fired equipment, the individual sites really relied heavily on the operator being able to manually go out there and make those adjustments. And the reality is that's always been a challenge to do so in a timely fashion. So that's really what a lot of these new technologies and even some of this advanced process control is more focused on, in making sure that that overall process in trimming excess CO2 is automated.
Great point, Walter. Great point. Any other comments?
Just to add to
Go ahead, Ben.
Chris's
Sorry.
point,
Sure, Ben.
Chris was talking about carbon dioxide and trying to control and reduce CO. I know there are a lot of technology out there for carbon capture and storage. So that's also a technology that's coming up where they're trying to capture that CO emissions and store it underground and repurpose it for other uses. So something to keep in mind.
Oh, great points. Chris, did you have a comment?
Yeah, you know, Walter had mentioned operator control, which was something that sparked a thought. And I just remembered an experience years ago where, you know, certainly we were really, you know, proficient at giving operator parameters on the low side in terms of maintaining oxygen, you know, making sure that we maintained, you know, proper equipment operation. But, you know, the issue that happened in this particular case, I mean, we weren't structured with some of the upper bounds. And so, you know, the operator is prioritizing running the equipment and running the unit, keeping it running safely, of course. And it's slowly but surely that percent oxygen, you know, crept up in the operation. And so, you know, while, you know, not an operational issue, it did cause issues eventually from a permitting standpoint, because, I mean, that was something that was flagged. And so, you know, and this is even before the days where CO2 was really on top of the list. And so now it just adds more complexity and adds more importance to, you know, making sure that you tighten that up with the right technology. Because again, it's just, you know, operators are going to do a lot of great things for you, but this is one where, hey, there's enough risk and justification to help give them a tool to be a little bit more proficient at, you know, balancing safety, environmental, as well as operability.
Oh, thank you, Chris. Any additional comments? Good discussion. We'll get to the next slide here. Now, slide 3 is really focused on the end users. So Chris, I'd like to kind of start with you. And, you know, what are some of the biggest challenges for end users when adapting to these newly implemented regulations? And where is the biggest win for them for, you know, to further improve their operation?
Yeah, absolutely. So biggest challenge, I mean, there's a couple in no particular order. You know, obviously from a cost standpoint, I mean, just from a business standpoint, you know, when you start to look at environmental carbon dioxide reduction type projects, I mean, you know, these typically can be costly. I think as we've mentioned on the panel, there's some ways to where technology is catching up to lessen that constraint, but in many regards, it's definitely something that, you know, is a huge challenge. I think the one of the other considerations is, you know, timeliness. You know, I think there's a lot of peer pressure in our industry. I know, well, I say peer pressure, it's really peer pressure from other competing entities, you know, from customers and vendors in terms of aligning ourselves with both customers and suppliers who actually have similar ideals in mind. And so, I mean, certainly, you know, it's balancing some of those considerations. It's very important to make sure that, you know, we keep momentum going, because again, I think as we've mentioned a couple of times, just justification for a lot of these projects, I mean, you got to dig a little deeper. You know, it's not going to necessarily meet all of your metrics from a traditional ROI or return on assets, or however you define, you know, your project productivity. But at the end of the day, I mean, I think it just really changes, you know, how we look at, you know, projects and justifying such. And that's where I think the challenge is really just trying to recalibrate ourselves to the new normal.
Oh, thank you, Chris. Let's go to Walter. Any comments, Walter? I think you're on mute.
Thank you very much, Dan. Hey, being an equipment supplier and looking at it from a very, very different perspective, you know, and Chris just mentioned this, it's pretty clear that whenever you take existing equipment that has been engineered and designed to produce the products that our society needs, and you're now asking to modify that equipment and to change it, it does become one heck of a balancing act. And what's really important is that the technologies that get applied, that we have the time to prove them and then have the time to get them implemented. And that's where there's sometimes a disconnect with some of these regulatory bodies with what can physically be done today, what can be actually achieved, and the time that it's going to take to get there.
Yeah, great points. I think about here in California and some of the carbon credit projects and some of the pain points to the end users. And then when I get information, to your points, Walter, about lower fuel consumption, which is ultimately, and having to heat less air and burn more efficient, and to hear the win from the end user on how many millions of dollars they're saving in now operating their equipment, I think that comes down to some of the proof there with the onset of new technologies and with regards to some of these regulations. Ben, do you have some points?
I think Chris and Walter captured it well. When you start looking at transforming, your energy sector and your existing infrastructure, it's going to cost. And that cost comes in the forms of technical advancements, economic constraints, financial. And the best advice I can say is the leadership needs to get proactively ahead and start fencing monies specifically for these type of projects. As Chris indicated before, it's not something that you can go penny pinching. Walter made it very clear. The technology is going to cost you. And on top of it, right, you're going to have to make sure that all of these modifications to your equipment meets the growing Herculean task of meeting federal and state environmental law.
Oh, thank you, Ben. Any other comments on the question? I think we'll move to the next question here. And now we're kind of digging deeper, and I think this is a perfect question we'll go straight to Walter for. And, regarding fired heater equipment, what are some of the benefits in the reduction of excess O2, and how does that change the overall operation of the heater for the better?
Oh, wow, Dan. How long do we have in this thing?
We've got some time.
No, all kidding aside, your typical heater, which was designed perhaps 30 or 40 years ago, can benefit immensely from proper control of the excess O2. Now, without question, just to give people a feel, most heaters today are designed in accordance with API 560, which asks that the heater be designed and the associated guarantees based on 3% excess O2. Well, most fired equipment out there in operation today is operating at excess O2 levels well above that, as high as 6, 7, 8, 9% excess O2. And so what that does to the heater over time is it changes the functionality of how the heater was designed to absorb the heat, depending upon how much it gets absorbed in the radiant versus the convection. There's actually a shift associated with that, which could damage the fired equipment, especially operating at long term. And other issues like, ultimately being forced to have to operate the heater positive pressure, that's another concern or an issue. Let me paint that picture for that particular aspect. when we size a stack, it's sized to draw in a certain amount of flue gas during maximum operation. Well, you can think about it this way. If you're drawing in a bunch of extra air that you do not need for the combustion in the process, not only does it cool off the tubes, not only do you have to fire harder to make sure you're not cooling off the tubes, but it also creates a large volume of flue gas air mixture that could potentially limit how the maximum capacity that you can run that heater at. So there are multiple different things that impact the heater when you run at excess or at higher levels of excess O2. Now, before I finish, I had a gentleman come up to me the other day and he told me that he wanted to run the heater at 0% excess O2. I had to explain to him that we would strongly recommend not doing that. There is a reason why that 3% is captured in today's industry standards. And it's because it's important during operation of a heater that you have the fuel and the air mixed in the proper ratio together where you're having the ignition take place. And on some of these bigger heaters, that can become a real challenge to make sure that you have that proper mixture. That's why excess air, now there are heaters in service today that are some of the pyrolysis ethylene, some of the steam methane reforming heaters that are safely running at levels of 1.5%, 1.75% excess O2. But you always have to look at the heater and then look at how it's instrumented and its controls to determine really what is a safe level to run from an excess O2 perspective.
Walter, is it true that years ago that most of these heaters that they have oversized fans and ducts with the onset of excess air simply because they didn't have the technology and the controllability that's available today?
That's generally a true statement. I mean, back when calculations were done by hand compared to utilizing sophisticated CFD modeling software today, we can definitely fine-tune the design much more. But a lot of that overage, Dan, was really built into the original design basis, wanting to make sure that, you know, we need the heater to produce so much capacity, but let's put an extra 10 or 15% on top of that margin in the design just to make sure that we have enough capacity. Well, it's that oversizing that takes place that then on the flip side of the coin makes it a huge challenge in many cases to properly control the excess O2.
And furthermore, Walter, when you're running lower excess O2, how does that affect the overall operation as far as the refractory? You mentioned the burner tubes, the burners themselves. What are some benefits in the overall longevity of the furnace?
When you can safely operate that heater closer to that 3% excess O2 mark, which is really its original design basis and probably 98% of the cases out there, you definitely do prolong the life of the components themselves, without question. And it's much safer to operate, provided the heater has been, from a mechanical perspective, from an instrumentation perspective, and then ultimately from a controls perspective, been upgraded to allow you to safely operate at those levels. But to that point, Dan, you could take literally any heater in existence, even one that was built in the 1960s, and retrofit it today to where it can safely run day in, day out at 3% or even slightly less than that excess O2 safely.
Great points, Walter. Ben, any comments?
It's hard to follow the expert advice just given by Walter. I think he did a fantastic job. No, I don't have anything else to add.
Chris?
Yeah, I mean, similar to Ben, I mean, definitely think Walter hit all the high points. I mean, just as Walter was speaking, sharing some of his feedback, it resonated with me. I mean, spending many years in the plant. I mean, and I think it emphasizes, the desire to run at a minimum at that 3% O2 excess, because from a prolonged equipment standpoint, I don't know about you all, but I've never had a outage of a piece of fired equipment that was actually very timely. It always is if it's not a preventative maintenance job, it seems to be always at the wrong time. It always seems to take a very long time. And from a productivity and cost standpoint, that's definitely the worst thing you want to happen. In terms of fired equipment, it's a critical utility in the plant, right? And so you want to be able to make sure that it lasts you for as long as possible, that you can control the maintenance on it as much as possible. And like I said, especially refractory burner tubes, those are just resonating as painful, costly things where eventually that cost will come. I mean, if you run a piece of equipment long enough, but I think, responsible operation, maintaining it within the range that Walter suggests really can certainly, I guess, maintain your level of calm as an ops person, just to make sure that your equipment does what you need it to do when you need it to do it. So that's all I've got.
Hey, thank you, Chris, for the comments. So we'll move on to our next question here. And this question will start off with Walter, then we'll go to Chris, and then we'll go to Ben's comments. So Walter, from a process, equipment, or a safety perspective, what are the biggest challenges in successfully reducing excess O2, and how are they mitigated?
Okay, the number one challenge truly has been getting people to understand the importance of controlling excess O2. I think it's always been something that it falls into that bucket of, well, yeah, it'd be really nice if we could, but when they look at the associate ROI based on how inexpensive natural gas is, they can never really justify it. Today, that narrative is quite a bit different, and it is because of our societal focus on carbon capture. So the biggest challenges to successfully reduce excess O2 from a nuts and bolt perspective on a typical piece of fired equipment, starting at the very top and walking down, most heaters were supplied with a stack damper that, from a mechanical perspective, just cannot properly control the draft at the arch of the heater where it needs to be. And you get a lot of not only repeatability issues, but you also get a lot of hysteresis, which causes the draft pressure to bounce around back and forth during operation, which then impacts how the rest of the heater operates. So the stack damper is very key. The next thing is instrumenting the heater to where you understand how much excess air or excess O2 you have in the firebox. Because if you're not measuring that accurately, but yet you're trying to drive down the amount of excess O2 to levels of 3%, 2.75%, you now potentially created a safety issue. So understanding the importance of that measurement, how it's taken, where it's taken, how quickly you get that response becomes extremely important when you're trying to safely control excess O2. The last item, well, I'm going to give you two more items. One of the other bigger challenges is a lot of these facilities will have the fuel that they use in the burners, the associated heating value or BTU content fluctuate. And it fluctuates in all kinds of different ways due to all kinds of different events. And it can become a real big challenge for the heater that's operating at tight levels of excess O2 to all of a sudden have the fuel that it's burning change dramatically, because the amount of air that's required to safely burn that fuel changes right along with it. So proper measurement and mitigation of that as part of the overall fuel system becomes really important for the heater, safe operation. The last item that is always a challenge is that with the exception of heaters that were designed to be balanced draft, which basically means the flue gas and the combustion air is moved by large industrial fans, those heaters, you have the ability to control the excess O2 better in most cases. But that's a small percentage of the heaters that are in operation around the world today. The majority of the heaters today are what we refer to as natural draft. So as far as generating the draft, it relies very heavily on the performance of that stack damper that I mentioned earlier. But it also, for many, many of the heaters, almost without exception, relied heavily on the manual control of the amount of air going through the burner registers. And that would be on a burner by burner basis, and that would be done directly by the operators. So getting people to understand that you can automate that you can now capture that as part of your control logic, only frees up the operators to, I think Chris had said it earlier, or Ben, it frees up the operators to really focus mostly on what's important, which is the safety and the operation of the heater.
Great points, Walter. Chris, would you like to chime in?
Absolutely. Again, Walter hit a lot of the high points. I mean, the one thing that resonated with me just listening to his response is the dampener, because, you know, from an operation standpoint, I think one of the challenges, in addition to what was listed, is really the human factor, right? I mean, you know, if you're trying to adjust a natural gas furnace or burner for that matter with the manual dampener, it's really hard, right? And it's easy to get discouraged, you know, in terms of just establishing what's the proper position. Of course, that's a very dynamic situation, so constantly in flux, constantly changing. You know, you've got human factors involved. You know, operators again. I mean, that's what Walter reiterated. You know, we have to keep them focused on operating the unit safely, right? And so it's a hard ask to maintain that, just because of all the other factors and the variability and the just the crude nature of that particular equipment. And I think the other thing that really I'll say, and I don't mean this in a bad way, but sometimes, you know, if you think about, you know, permitting and some of the risks that you're taking there, you know, there's a tendency to want to, you know, overshoot on the oxygen, just from a matter of just maintaining all of your other permit requirements for a particular piece of fired equipment. And in some cases, you might even have that prescribed, depending on your location, how that's documented. And so, you know, there's a conservative nature in terms of, you know, trying to manage that risk as well. And I'm sure Ben may have some other, you know, feedback there. And so I think that's a challenge as well, because it does, all this kind of goes back to human behavior, human performance, just really creating different experiences so we can fundamentally change the beliefs of the folks operating equipment. Again, I think that really pairs nicely with everything Walter had mentioned earlier in his response.
Well, thank you, Chris. Before we go to Ben, Walter, you mentioned the stack dampers and in the reduction of excess O2. Would it not be important to the end users to also look at the design of their stack dampers, the blade design? From an air controllability standpoint, it sounds like Barocco USA could provide additional consulting regarding the review of some of these old and aging stack dampers and what they're really controlling.
Yeah, I'm glad you brought that up, Dan. I was already way too long-winded, so I stopped talking. But, you know, without question, I think if you look at the history of a particular heater, odds are that damper, when it was originally built, had cables down to grade, and it was manually operated, that stack damper. And then over the years, somebody thought, well, let's automate it. Let's slap on an actuator. And that kind of works, But what a lot of people didn't realize was that original damper was a very simplistic, some pieces of plates, maybe some pipe shafts. It was never engineered to provide the level of control that today's requirements demand. And I refer to it as the bigger hammer. When people put an actuator on a existing damper, well, it doesn't work, so let's just get a bigger actuator. That's really, if you want safe, reliable, repeatable control, the damper itself really needs to be engineered to work in harmony with the actuator that it's using. And then the damper itself needs to be able to provide the control engineered to meet the performance, the process requirements of that particular heater. And yes, we do that all the time, Dan, because it's an extremely important thing to get right. Once you do, you're well on your way to being able to control the excess O2 in that heater much more reliably, much more accurately and reliably day in, day out. Now, the one thing I didn't mention was most people don't realize that you can automate the amount of air that goes through the intake of the burners. And we work with Rexa. We use some of your components, your actuators, on what we refer to as our compensator technology, which can be retrofitted on the heater while it remains in service, which then allows you then to be able to automate the control of the excess O2. So did that answer that question, Dan?
Yes, thank you, Walter. And I think what I'm hearing from the entire panel, and maybe something to just throw out there, is that it seems to me that the discussion is now more about a complete control solution, whether it be through instrumentation, controls, damper design, burner control. I'm really hearing kind of a theme of multiple technologies working together for a common goal that ultimately brings us to a more efficiency, less carbon output, and meeting all of the regulatory and future controls aspects. So this is really powerful stuff. Ben, what's your input here on this question?
My input is going to be more towards the safety perspective. As you look at the multiple technologies and advancements that you are probably going to consider for retrofitting and reconfiguring your fixed equipment, it's important to understand that from a human performance perspective, you got to make sure you have the right PHA, process hazard analysis, that's done. Because even if you have great equipment, if it's not operating within the boundaries and limitations of the compliance regulations, you're not going to be able to operate your plant on that new exciting piece of equipment. And then most importantly, as Chris mentioned, procedurally, make sure you have a good solid procedure and a good training program, because at the end of the day, when Walter comes by and he helps you retrofit your piece of equipment, you got to make sure that that end user and that operator has the right set points and understand what the operating envelope is, so he can drive that new piece of equipment in a safe manner. Thanks.
Thank you, Ben. I think one of the things I always see forgotten is the concept of improved safety. For some reason, it's never at the top of the list, but when I think we can all agree, if you have a better designed damper with controllability, you have a better final control element and less uncertainties, you've redefined your control system. The hope is that not only that you're running more efficiently, but you have a safer operation for the employees and for everyone. So I'm so happy that you see the importance of safety and what it means to so many workers in the market today. Any other comments on this question? Okay, we'll move to the next question. I think we're coming towards the end of our webinar, and this one's really kind of a takeaway question. I think we'll start with Ben, and then we'll go to Chris, and then we'll end with Walter. And really, guys, it's what's your outlook for the future for the industry and really meeting these challenges long term? And what's the biggest takeaway you'd want today's audience to leave this webinar with? So we'll start with you, Ben.
Sure. Again, as I indicated when I started here, the energy sector globally has the Herculean task of managing this decarbonization effort that's in place. As we look at the net zero goal of 2050, it's important to understand that there are limited resources, which means, and Chris brought this up, cost. So as you look at your technologies, as you look at running a safe and stable operation by improving infrastructure, the best advice I can give is to make sure that your shareholders, your stakeholders understand the importance of fencing monies, all right, to subsidize all of these required technologies. And I'm talking about equipment improvement, permitting, and compliance requirements. They all go hand in hand. Bear in mind, because of limited resources globally, the logistical nightmare it's going to create for you. So having a set funding for your CN and decarbonization program, I think, is paramount and very critical to the success of your program.
Thank you, Ben. Thank you. Chris?
Yeah, so a couple of things I think about. I mean, outlook for the future, right? I mean, it's definitely just the latest example of how our industry has progressed, I mean, by leaps and bounds over the history, right? You look at the last 20, 40, 60 years, there's been a number of challenges, right? And so I have no doubt that, we'll be able to overcome this particular challenge. I think at the beginning of the journey, right? I mean, there's a lot of learning, a lot of development, technology advancements. As we've discussed today, even with our fired equipment furnace scenario, where hey, the technology is much better than it is, than it was, years ago. And so I think that evolution continues. And I think at the end of the day, I mean, the good news about this challenge is that, I mean, hey, this is something that's industry wide. I mean, collectively, many entities, many companies, other service providers, everyone together is looking at how do you tackle and solve this problem. And so that's really what gives me, hope and excites me about the future is that, I mean, just with the history, the track record of our industry, really tackling the largest issues. And I mean, decarbonization is something that's, next on the list of what we're going to have to tackle. And so that's really, in terms of what the audience takes away, I mean, that we'll continue to evolve, we'll continue to advance technology, we'll learn from one another. And I truly feel like, I mean, this is something where I think the road may be a little bumpy, now, but as we progress, as time goes on, as we learn more, we're able to standardize and get a little bit more structure to how we can effectively tackle the issue of technology and different approaches to our work. We'll definitely continue to move in the right direction. And so that's my comment for now.
Oh, thank you, Chris. Really appreciate your comments. All right, Walter, bring it home.
All right, Dan, not to get too philosophical, but over the years, I've come to realize that our very society's foundation is built upon a lot of our industry, not only in the the fuels, the energy that we need to heat our homes, to run our cars, but also in the everyday items like plastic that's used for IV bags, things like that. Our technologies, both on the refining and on the petrochemical side, have gone hand in hand with the development of our society over the last 20, 30, 40, 50, 60 years. And that's not going to change. What we do is extremely important for society. Looking back, and I think Dan had mentioned it, or I think Chris had mentioned it a moment ago, no matter what obstacle our industry has been faced with, we've always took the challenge, met it head on, and directionally get to where we need to get. But it does take time. And we had mentioned that in some of the earlier conversations. What really excites me about today, Dan, is the fact that we're having these conversations. We're very seriously having these conversations. And I think everybody's listening all the way around, which is what it's going to take for us to be able to come up with the absolute best solutions and still be able to provide, you know, all of the various products that our society needs. That's the takeaway.
I appreciate those comments. I guess on the West Coast, where I'm from, I don't think we're going to see new refineries being built. But do you see that the challenge long term within these industries are about retrofitting their existing equipment and utilizing the technologies that are available to increase their process and their output? Is that, to your opinion, what you think will come in the future?
Wow, we don't have enough time to really go too in depth on this. But at a really high level, Dan, I think without question that every petrochemical facility and every refinery in the United States will be needing to make these decisions based on the future forecast demands for the products that they produce. Now, having said that, let's talk about the refining side of things just for a minute. You know, everybody is forecasting that the actual demand for refined products is actually going to plateau at some point in the next 10 to 15 years. What a lot of people don't realize is that it may plateau globally, but it's going to be those developing countries where we're going to see the greatest demand or increase in demand. So getting back to this particular panel and this discussion, all those factors need to be taken into consideration when the decisions are being made. And there will be some folks that will decide that their facility here in the US perhaps isn't best to keep running. But it's really going to be those folks that take the initiative and make their equipment the best that it could be that will help ensure their long-term operation and profitable operation for many years to come.
Yeah, great points. It's that's the future. I really appreciate your input, Walter. We have a little bit of time left. If it's okay with the panel, there is one question that's come in, and it is, what role do renewable energy sources play in the transition towards carbon neutrality within the petrochemical industry? This is a new question that's come in. We'll start with you, Ben, then we'll go to Chris, and then to Walter.
Sure, real quickly and very high level, the whole idea of looking at new energy renewable sources, which we call the alternative energy source, is the key driver to this process. You just have to find a way to cost effectively make these changes and retrofit it into your existing framework. When we speak about these renewable energies, we're speaking about wind, solar, hydropower. These are all the key factors that individuals would be looking at as we drive towards net zero.
Thank you, Ben. Chris?
Yeah, absolutely agree with Ben 100%. I mean, high level, I mean, those are definitely key parts of the energy transition. I mean, I know organizations are already moving in that direction in terms of solar farms. I mean, if anyone has driven through West Texas or a lot of other parts of the U.S., I mean, you see a lot of wind turbines, and so definitely a strong market for that technology as well. But I think the key, like Ben said, I mean, these are all, you know, more carbon neutral type approaches versus our traditional energy generation. And so the more we invest in that infrastructure, the more we sustain it, the more, I guess, the more pressure is lifted from more traditional ways of energy production and CO2 reduction. So again, no easy task for sure, but I think that's definitely a key. Renewable energy is a key component of, you know, the future here.
Thank you, Chris. Walter?
Yeah, I think, I've had a lot of conversations, not only with my family and friends, but also with colleagues on this particular topic. And I guess what I would encourage the greater world and our industry to be focused on is being open to the transition, being open to these new technologies, but carefully vetting them to make sure that they truly do make the most sense. And by that I mean, today a lot of the renewable technologies out there that are being considered actually don't necessarily make the world a greener place, because the amount of energy required to get them and or to produce them is greater than other traditional methods. So while I'm really pleased that our world is focused on making the world cleaner and better for us all, we can't lose sight of the practicality of things. And that's us as engineers, us as being members of the either refining or petrochemical industry. We need to make sure that the greater world understands that.
Yeah, great points, Walter. I think this was a really valuable webinar. At this point, I want to thank this entire panel for your time, your years of experience, and your expertise. I've certainly learned and enjoyed the experience. And at this point, we'll turn it back over to Marcus Evans, and we'll end this webinar.
Thank you so much, Daniel, and thank you so much, panelists, for your great insights and for your time. Audience, please answer to the brief survey that is going to pop up on your screen. It will take a minute or two. And also mention that in the next 2 hours, you will receive an email where you can also look the webinar on demand. On behalf of Rex and Marcus Evans webinar, thank you all for your time, and we do hope you'll be listening to our webinar. Thank you so much for your time.
Thank you all.
Thank you.